Imagine a futuristic city where every variable is a glowing orb of energy, floating inside vast, interconnected rooms. This is Code City, where JavaScript comes to life. Today, we're going on a journey through the invisible architecture that powers every line of code you write. We'll explore global scope, the city plaza where everyone can see everything. Function scope, private rooms with their own secrets. Block scope, secure vaults within those rooms. Then we'll journey deeper into the hidden chains that connect them all. Scope is the engine that decides which variables you can access at any moment. Think of it as JavaScript's access control system, a set of rules determining who can see what and when. Global scope is like the main plaza of Code City, wide open, visible to everyone. Variables declared here glow brightly, accessible from anywhere in your program. When JavaScript starts executing, it creates this global environment first, laying the foundation for everything that follows. But when you create a function, JavaScript builds a private room around it. Variables declared inside are locked within these walls, invisible to the outside world. This is function scope. The function owns its variables completely, protecting them from interference and creating true encapsulation. Then came ES6 with let and const, introducing block scope. Now, even within a function, you can create secure vaults using curly braces. If statements, loops, even standalone blocks, each one creates a new boundary. Let's see it in action. Here's a variable in global scope, visible everywhere. Inside this function, we declare a local variable, private to the function. And inside this if block, we use let to create an even more restricted variable. Watch how each layer creates a type. Pause for a moment. We've just explored three fundamental boundaries: global, function, and block. Each one controls what variables can be seen and accessed. But here's where it gets interesting. Meet lexical scope, the blueprint that's drawn the moment you write your code. Lexical means related to the text, and that's exactly what this is. Under the hood, JavaScript creates something called a lexical environment for every function. When you nest functions, you're building rooms inside rooms. Each inner function has its own scope, but it can still see everything in the outer function. That's because its lexical environment holds a reference to the parent. This creates a living connection between nested scopes, enabling inner functions to reach outward whenever they need to. Now watch what happens when JavaScript needs to find. Let's trace a real lookup. We're inside a deeply nested function, trying to access a variable. JavaScript checks the local environment, not found. It moves to the parent function, not found. Finally, it reaches global scope and finds it. The lookup walks the chain, step by step, until success or failure. Here's a practical example. We have a global variable, and it sees its own scope, the outer function's scope, and the global scope, all connected by invisible links. Take a breath. We've just witnessed the invisible chain that connects every scope in your program. This chain isn't magic, it's deliberate design, and it's about to reveal something powerful. Here's the revelation. Functions don't just see their parent scope while they're running. They remember it forever. When a function is created, JavaScript locks in a reference to the lexical environment where it was born. Even if that environment disappears from the call stack, the function keeps it alive. This is the foundation of closures. This is a closure, a function that carries its birthplace with it. When you return an inner function from an outer function, the inner function keeps access to the outer variables, even after the outer function has finished executing. The variables don't vanish. They're preserved in memory, frozen in time, waiting to be accessed whenever the inner function is called. Let's see a closure in action. This outer function creates a variable but the inner function we received still has access to that variable. Call it once, twice, 10 times, it remembers. The closure keeps the outer scope alive. Closures enable data privacy, function factories, event handlers, and async callbacks. They're the reason React hooks work. They're why you can pass functions around, and they still remember their context. Closures are the invisible glue holding modern JavaScript together, powering patterns you use every single day without even realizing. Let's zoom out. Global scope at the base. Functions creating their own environments. Nested functions building rooms inside rooms. The scope chain linking them all together. And closures, preserving access across time and space. This is the complete architecture of scope, the invisible skeleton supporting every program you write. The camera pulls back, revealing the entire interconnected city. Variables glow in their rooms, functions pulse with energy, and the scope chain lights up like a neural network. You now understand what happens beneath every line of code, the living, breathing system that is JavaScript scope.